Hi and welcome to Unit 2, Topic 2, Video 8. And in this video we're going to finish our work on basic trig identities, the introduction part of this topic, and solve some trig identities. So these are proof questions, and most exams will have one or two of these from now on. So it's definitely worth getting used to them and being able to solve them. So the first one, A, is I prove that, and it's got a sec and a cosec. Now, this is a long way from being definitively true, but I often look at that and think instantly, how on earth am I going to remove the sec and cosec? Because I want to head towards my basic trig functions, tan, sine and cos. But actually, more importantly, I find success often comes in moving as quickly and as close as I can towards sine and cos. Just not even tan. Sine and cos does a lot of the work. But again, I just want to reiterate, it's not always true. So practice will really make you quite good at making good choices. So what I do want to recognise though is that there's a nice relationship between sec and cosec and cot and tan. And cot and tan get us really close to sine and cos nice and easily. So I'm going to work on that relationship. And that relationship comes from these two Pythagorean identities that are on your formula sheet. So the first one is that sec squared theta and tan squared theta are related. We get 1 plus tan squared theta is equal to sec squared theta, which leads to 1 minus sec squared theta equals negative tan squared theta. And equally, we get something like 1 plus cot squared theta equals cosec squared theta, which leads to, that's cos, sorry, cosec squared theta, which leads to cosec squared theta minus 1 is equal to cot squared theta. And so when we put all that together, I think this should actually say negative 1 here, my apologies. When we put all that together, I can see that 1 minus sec squared theta is negative tan squared theta times by cosec squared theta minus 1 is cot squared theta. So I should actually probably, I'm marking this up at the moment. Let's start by rewriting the question just so that we've got our full proof. So I'm going to start with left-hand side is equal to 1 minus sec squared theta cosec squared theta minus 1, and that's equal to negative tan squared theta times cot squared theta, and that's equal to negative sine squared theta over cos squared theta times cos squared theta over sine squared theta. Cancel, 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 cancel. That is equal to negative 1, which equals the right-hand side of my renewed question, as we expected. Now, a couple of things here to note is that that's a single term, whereas these guys are double terms. And if I expanded those brackets, which a lot of students would do, I'll end up with 4 separate terms. And it's really hard to get 4 separate terms down to 1 term. So I'm actually looking for a way to bring it towards 1 term. I'm looking for a way to have this equal to a single thing, because then I've got 2 single things multiplied, and then things will simplify out. The other thing is I have faith. Always have faith. It sounds ridiculous, but the question will work out. So as long as you're making the right choices, heading towards cos and sine where you can, and simplifying it down to match the number of terms, things typically work out quite nicely. It's very rare that you take a wrong path and end up with something that's mathematically correct but too far away from the answer you're looking for to get back to it. So let's have a look at part B. Again, my analysis is that this is cos theta. It's just way too simple for me to do anything with, but I can do stuff over here. So my aim is to do stuff to the to the right-hand side this time, and simplify it down to the left-hand side. So cosec theta, tan theta, and cot theta. Part B. I'm going to say the right-hand side is equal to cosec theta over tan theta plus cot theta. So I'm going to take that approach this time. And it's going to get messy to start with, but I'm going to head towards cos and sine. So this is equal to cosec theta is 1 over sine theta over tan theta plus cot theta is sine theta over cot theta plus cot. So tan theta over cos theta plus cos theta over sine theta. Now this is a little bit too messy for my liking, but I'm going to keep it as a single fraction for one more round, and then we'll move away that 4-part fraction. So I've got 1 over sine theta here, and then the denominator, I'm going to have sine squared theta over sine theta cos theta. Remember back in year 7, 8 we talked about that cross multiplying to get the same denominator. That's my aim here. So I've multiplied this side by sine theta over sine theta so that I end up with a sine theta factor in the denominator. I'm going to do the same thing over here. I get cos squared theta over sine theta cos theta. Now you could probably skip one of these 2 lines, but I'm going to be really thorough. That means, and it's a bit annoying because it's out of hand at the moment, this is equal to sine squared theta plus cos squared theta all over sine theta cos theta. Okay, so I've still got that 4-part fraction, but I know how fractions work. If I've got a fraction divided by a fraction, it's equal to 1 over sine theta times the reciprocal, sine theta cos theta over sine squared theta plus cos squared theta. I can cross simplify, the sine thetas will cancel out, and of course sine squared theta plus cos squared theta is equal to 1. That's our Pythagorean identity, so end up with 1 over 1 times cos theta over 1, which is equal to cos theta, and that's equal to my left hand side as required. So there's my proof. You can throw a QED in there and as required in there, a smiley face, although it's not technically the best thing to do. So I'd probably just leave it there or throw in a QED. So there's our second example. And there's going to be many more to follow. There's going to be plenty of examples in other places on the internet and in your resource textbook. But just keep in mind this is a basic trig identities. We haven't got into double angle formula yet. There's a few other things that we'll see. So you might find certain other examples, if you're not looking just in your textbook, actually provide you with things that you don't need yet. So just be wary and mindful of that. But otherwise, there's a good start with some strategies for you. Go forth and practice. All the best.